Okay, so I'm gonna explain about how you guys going to do lab 4. Right, so first of all lab 4 will be based on the lecture note that I give to you guys. Right. Uh, all right, so it will all be based on the lecture note given, which is in your uh, week 4 HDL part 2. Right, basically we have to write all this code into a different very long file in your quarters. So as you guys can see, I've already typed the whole code. For example, marks 32 2, this is 2 to 1 marks, and then this is 3 to 1 marks, and then we have the multiplier block, and this is the subtractor block, and then here is the addition block. Right, so this is our top level module. So again, what is the top level module? This is a module where we connect all the small modules that we have. So you guys can look on the tab here, right? As you guys can see in the tab here, so this is your top level module. Right, so top level module, if you guys can, what do you call it? This is expand, right? If you guys close it, then you guys can see only the top level module. And then if you want to know what are the modules that being connected to the top level module, so you can expand it. Then you can see we have like 1, 2, 3, 4, 5, 6 modules that sit under the top level module, which is lab 4. So where does this connection occur? So it occur here. You can look in the code. So for an example here, right? We are using 2 marks 32.2. So that's why you can see we call this block 2 times. And then here is the custom name that we want to give, right? So in this case, we use it for the first time and we give the name as adder marks to marks 32. And then we use it again, then we give another name. You cannot give the same name, right? It's gonna give you error. So you have to give different names. So here is a sub marks. Right, then we just use add 32 one time, sub 32 one time. So you can use it multiple times. It's depend on your usage, right? So for an example, you just need to use the other of the block apart from marks 32 just one time, right? So that's why we can see the connections occur like this, right? And then here you have to follow the order, right? The order of the connection. So how you want to know the order, you have to go and check in the original file. For example, marks 32.2. So you have to open the marks 32.2, right? And then you see the order of the connection is starting from I0, I1, select out. And then you have to check the size of the input and the outputs. For an example here, the input I0 and I1 is 32 bits. So that's why 032. And then select the size is only 1 bit, right? Because there's no size being declared here, so that means it's only 1 bit. And then out is also 32 bits. Okay, then remember I0, I1, select out. Let's see at the top level module. So it is I0, I1, select and out. So remember I0 must be 32 bits. So B here we declare it as 32 bits. Okay, that's fine. And then here we are connecting 32-bit lines, and the value of this 32-bit is decimal 1, right? So that means it's a 0, 0, 0, and the last bit gonna be 1. And then here we just take only 1 bit from F. So example here, F has 3 bits, right? 0 to 2, 0, 1, and 2. So that means there are 3 bits for F. But we only need 1, right? Because you look at the module here, we just need 1. Select is only 1 bit. So what happened is that we just connect F0. Right, so there are 3 bits for F0, F1, and F2. So in this case, we just connect F0. And then finally, add max out. So we need to have 32 bits. So in this case, we need a wire to connect the output from the adder to different modules. So we create a wire here. So we name the wire as add max out, and then the size of the wire 32 bit. It has to be the same as the size of the output because we are connecting it to the out. All right. Okay, and then the other thing that you can do is that, I mean, to look on the block diagram, right? So, I mean, last time I've shown you how your design looks like after they map it, which is you open the technology map viewer. But if you want to look it in a block diagram that give more sense to us, so you can open RTL viewer. So if you open the RTL viewer, then you're gonna get a block like this. So this is how your circuitry looks like. Right, so this whole part is under your top level module, which is lab 4. So you can see here we have 6 modules that being connected to each other. Right, so as we can see, I mean, there's a MALS 16. This is the original block name, and then this is the name that we give, right? So our multiplier, you can check in the code here. So look at your top level module. So here is MAL 16, right? So it's a MAL 16, and the name is our multiplier. So this is the block here. And then you can see all the connections, how it being made. So this, I think, gonna help you to give more sense what are you guys doing on this part, right? So these are just connecting the blocks that we have. Right, so finally, all the output of the adder, subtractor, and also multiplier will goes into marks 32 3, right? So this is 3 to 1 marks, right? Okay, what else? I'm gonna let you guys know. All right, so okay, let's see here. All right, so for example here, let's take this adder marks 32 to adder marks. Okay, let's find which one is the block marks 32 to adder block. So this is the block here. All right, so what we can see here, we have 3 inputs, right? So we have 3 inputs: B 32 decimal 1, 32 bit decimal 1, and then F0, and here is your output, right? So we can see here. So here we have select. So select just being connected. I mean, they're not specifying which part of the F that we connect to select, but we can see here I0 size is a 32 bit 0 to 31, and here we can see I1 is being connected to 32 bit, and the value is 000 and then 1. So the LSB here is 1. All right, and then you can see the output here is being connected to a wire, and then the wire is connecting the block of marks 32 to adder marks to add 32, our adder. So where does this connection occur, right? So you can see here. So add mark is a wire. So this is one end of the wire, this part here. And then we connect this wire to add 32. So you can see here, the other end of the wire being connected to add 32 our adder. So it's here add 32 our adder, and then it's also being connected to add marks out. All right, so that's how the connection occur. All right, so in your case here, so I mean, I think this is straightforward. You guys can copy it, compile, and then you can try to simulate it. Okay, then what are the modifications that you guys need to do, right? So I'm asking you guys to add another 2 blocks. So that means they're gonna be another additional blocks, 2 blocks here. Okay. Oh, all right. Okay. That's the pen. All right. So what you guys need to do is that you guys need to add another 2 more blocks, right? So let's see, there's 1 block here, and then another 1 block here. Okay, what does these blocks will do, right? So one is shift left, and another one you're gonna be shifting to right. So I'm asking that you guys shifting just the A input, right? So you guys just need to add, I mean, the connection A into this block, and then connect it also to the shift right block. Okay, and then where does this output need to go? So of course it needs to go into the final marks here. So what happened is that of course you need to add some more input to the marks here. So you need to add I3 and then also I4. So this is the extension of the block here. And then the shift left need to go here, I3, and shift right need to go to the I4, all right? And then of course it's only one output. Okay, what happened here when you change the input? Of course you need to change the size of the select. It has to support up until 1, 2, 3, 4, 5 options here, right? So I think that's all that you guys need to do. And then how you guys going to do the shift left, shift right? Google it, right? So Verilog, shift left, shift right code. And then of course you're going to find one, do some modifications, then complete the connections. Voila, is completed. All right, submit, get some marks. All right, any question?